Hey everyone, my name is Chadwick Strange. Great to be here and pleasure to present to you all. Let me share my screen and go into the presentation. And just before that, I'm VP of Product at SKALE Labs, helping build the SKALE network. Okay, I'll be presenting today on scalability and non-fungible tokens. Like I said, I'm VP of Product at SKALE Labs. Pleasure to be here to presenting at this conference. For those of you who want to listen in and maybe kind of look at some code as well, you can go to the SKALE Network GitHub. So that's github.com/SKALE Network. All of our code, all of our examples are open source, so feel free to check out our repos. And we also have a documentation portal at scale.network/docs. And if you have any further questions or just want to talk to the internal team, you can join our Discord channel at scale.chat. And for anyone who's not a developer but interested in the project itself, we have a large Telegram community with multiple languages that you'll find on our main website. So there's plenty of ways to get connected and to ask more questions and get engaged with the team and maybe find out some grants and whatnot. So let's get into it. This is a chart of the Ethereum gas prices over the last 6 months. This is a really great tool called gasnow.org that recently came out. I use this tool quite often. I suggest you check it out as well. And as we can see here, over the past 6 months, gas prices on Ethereum mainnet have been very volatile with some crazy peaks, last September nearing 500 Gwei. And more recently, in the last couple of weeks, it kind of peaked up to 400 Gwei. This presents a huge problem for any dApp developer, whether you're developing with ERC20s or non-fungible tokens. It's a huge concern in understanding, one, what might be your upgrade costs or your deployment costs to get out your decentralized game or your NFT token if you're going to do an airdrop. Dropping it in September would be super costly, or even a couple of weeks ago. And not only is it costly to develop NFTs and different financial applications that use and leverage NFTs, it becomes a huge conundrum for your end users that might have to think twice about whether they can actually send an NFT or lend or borrow an NFT, given that they might incur maybe $100 worth of US dollar equivalent in gas costs just to conduct that transaction or whatever that functionality is with NFTs. And as dApp developers and NFT developers are getting very into recently is more complex transactions. So Ethereum network is really great for a proof of work system with great security, but people who are developing NFTs who desire scalability and engaging end users, they need to have a more scalable method to do this. And that's what the SKALE network is building. So SKALE network empowers Ethereum dApp developers to scale smart contracts in a secure, reliable, cost-effective manner with what we call Web3 cloud resources. So similar to the Web 2 world, where people who are developing SaaS services and different websites and functionalities, they can easily use Web 2 cloud resources like instances and droplets and whatnot. SKALE Network is providing Web3 cloud resources such that if you're developing an NFT or a game or a more complicated financial application using Solidity, you can get the resources that you need to run not only your application, but to also engage your end users in a way that you reduce the concerns around gas costs. And the nice thing with SKALE Network is that it's built on top of Ethereum. It's built to be 100% Ethereum compatible. So all the normal tools that you use for Ethereum, like Truffle, Web3, Ethers.js, and Remix as an IDE, you can also use on your SKALE chain. And your SKALE chain is basically an elastic Web3 cloud compute resource to launch and deploy your dApp and engage end users in running your dApp. In addition, your SKALE chain and the SKALE network, it's fully compatible with ERC20, ERC721, and you can use Ethereum wallets like Taurus, Portus, and any of the Web3 based API wallets with your SKALE chain. You can run stable coins onto it, and of course, you can run your NFTs on Scale. So how does Scale Network work? Scale Network is a platform. It's an open source, permissionless, decentralized platform where validators, represented by the hexagons above, provide node compute resources to the network. Think of these as your droplets, your instances, but for Web3. So these nodes are running these computer resources, these instances, these machines are running and are connected to the Scale manager or to the network itself. Is sort of like the orchestration layer that helps nodes register into the network and helps provision resources or Web3 cloud resources to dApp developers. So if you're building an NFT and you need a scalable resource, you can request resources, Web3 cloud resources or skill chains from the Scale manager and access these validator or compute resources in the network. Scale manager is a set of smart contracts that are deployed on Ethereum. So as validators or nodes register compute resources to the network, they're actually conducting transactions with the Ethereum mainnet in order to register on Scale Manager. In the same way as an NFT developer who's looking for a scalable resource can make a call to Scale Manager to request a skill chain to basically run and scale their NFT or their dApp that they're building. So in that way, which makes Scale very unique, is that it's an Ethereum orchestrated network. The entire network, the entire scalable resources are all allocated, developed, managed, and provisioned from transactions conducting on Ethereum. And that way, Scale Network as a scaling network is anchored right into the Ethereum mainnet. The key part of Scale Network is providing scalability that's still secure. And how we do this is something called randomness, rotation, and incentives. And I'll explain. The bottom chart, the cloud of dots here represent nodes that are provided by validators into the network. As a NFT developer, you want a scalable resource, you want a skill chain to run your NFTs to provide, or maybe another layer where you're providing a financial application that allows lending and borrowing of NFTs. You would request a skill chain, and out of the network, a subset of nodes would be selected, represented by the top subset, to run and basically provision your elastic blockchain or your sidechain system. So this set of nodes, which is set as a default to 16 randomly selected nodes, would be selected and perform your Web3 cloud resource to deploy your dApp. So these nodes are randomly selected. Each node is secured by a proof of stake, which is about currently 20 million scale tokens. And these nodes are rotated consistently over the lifetime of your skill chain. If you're running your dApp for 2 years, you could select a skill chain that would operate for over a 2-year period. And time to time, nodes would be rotated in and out of the skill chain. And this is a security layer to prevent potential collusion over time. You can imagine if you're a decentralized exchange or a DEX or some open exchange for NFT tokens, you want to make sure that the nodes over time are swapped out in order to keep a fresh set of validator nodes operating on your skill chain and to prevent collusion over time. And then each of these nodes, providing your skill chain or providing your elastic blockchain resources, they each run a containerized system that runs consensus, EVM execution, and a network client, just that basically mimics the Ethereum network, but in a very fast and scalable way. And within these containerized resources, you would run your smart contracts, your messaging, and storage. So again, your skill chain is selected and provided to you that's very dApp or application specific. So if you are running some application with NFTs or some game with NFTs, you would select a skill chain that meets your scaling needs. They can be different sizes. And so each different size can provide different block times, different transaction throughput, different storage, and messaging layers to power your dApp. So depending on the size or your growth, you could select a skill chain specific to those needs and to the configuration that you need to run your dApp. And over time, you can migrate to different other chains or other sizes as your dApp or as your user base needs. And that way it's fully flexible and elastic. To get a little bit deeper into the node architecture, so each node that is supplied to the network by a validator that registers with Scale Manager runs the Scale Network software or Scale Node software on their machine or their bare metal machine. And at the core of this node core is part of the functionality that helps allocate compute, memory, and storage resources from the machine itself to help power the Scale chain. And the resources of a node can be provisioned out up to 128 individualized containerized subnodes. So a single node can support up to 128 unique subnodes that will help power a Scale chain. So 128 Scale chains, up to 128 Scale chains can be supported by a single node, given a small size of a Scale chain. And each node connects to the Ethereum network and is talking and communicating to Scale Manager. So this node core is actively listening for whether there's a Scale chain request made by a dApp developer who's looking for a scalable resource. And the node core continues to interact with Scale Manager in terms of reporting health metrics and registration metrics onto the network. So again, that core helps provision or automatically dynamically resize resources of the node to provide scaling or Web3 cloud resources to dApp developers. And then again, these nodes can be provisioned in different ways. So on the left, this is an example of where an entire validator node can be supporting what's called a large scale chain. So this is maximum throughput, maximum storage resources, the largest size of Web3 cloud resources that can be provisioned to you. The entire allocation of a node can be provisioned, again, 1 out of 16 nodes that support your Scale chain. You would have full access to all the allocated resources for each of those 16 nodes. And in the middle shows an example where a validator node might be supporting nodes of or Scale chains of different sizes. So here it's supporting 2 medium chains, which is identified by the blue hexagons at the bottom, and then 3 small Scale chains. So you can see there's this multi-tenancy model where validator nodes can support multiple Scale chain sizes. So as a dApp developer, if you request a small chain or a medium chain or even a large chain, you can access different allocations of each of these nodes of the network. And on the right is a validator node that's unutilized that hasn't yet been provisioned yet to the network. So as a Scale network, at different times, there'll be different allocations or different mixes, and again, different swaps or rotations over time that these node resources are providing for Web3 cloud scalable resources for dApp developers. And then key to this presentation about NFTs, Scale Network provides native cross-chain bridge. We call it the Interchain Messaging Agent, or IMA. And IMA out of the box supports ETH transfers from mainnet or Ethereum testnets to your Scale chain, ERC20, ERC721, and can support any other token standard or arbitrary message using something called message proxy. So if you have something unique that you'd like to build on top of, you can use part of the modular protocol of IMA to build in any token standard or any other functionality that you wish. So the native cross-chain bridge is basically 3 parts. So there's IMA contracts that sit on Ethereum that manage the receipt, deposit, and the connection and registration for any other contract functionality needed for IMA to communicate to Ethereum mainnets or testnets. So IMA contracts on Ethereum help basically have that receipt or that standpoint on the Ethereum network. And then there's IMA contracts that are pre-deployed on your Scale chain. So again, this is natively built in. As a dApp developer, if you request a small, medium, or large Scale chain, these contracts will be pre-deployed onto your Scale chain. And so using IMA, you'd automatically use those pre-deployed contracts. And the third component is IMA Agent. So IMA Agent is a containerized resource on each of the 16 nodes that are provisioned to your Scale chain. And this acts as a relayer between Ethereum and Scale. IMA Agent is actively scanning for any events or updates on Ethereum mainnet, and it will, for any events or any custom events, it will relay and transmit a message over to a Scale chain, and then back and forth. And the great thing about IMA Agent that's also unique is that it's leveraging secure enclave technology, which is supplied by validator nodes, BLS threshold cryptography, such that any messages between the mainnet and the Scale chain are signed by a minimum threshold of signatures from the validator nodes to confirm or validate your transaction either from Scale or from mainnet. And then, of course, each of your 16 nodes, the IMA agent is staked by proof of stake, and that's currently 20 million Scale tokens per node. Times 16 gives you the idea of the type of stake that's supplied into your Scale chain. And the high-level flow for how you'd use the cross-chain bridge in IMA is first, there's a setup and mapping of your ERC 721 tokens. This also applies the same way to ERC 20 or any other token standard. And it can be manual setup depending on the dApp developer preference. If you want to manually choose which ERC 721 tokens will be compatible with your Scale chain, you can set that up manually and then map those ERC 721 tokens to your Scale chain. Or you can use an automatic feature, which will be released in later versions of the Scale chain, where any ERC 721 token or any other specialized mapping will automatically be cloned on the Scale chain. And when you set up and map your ERC 721 tokens, the key difference is that on the Scale chain, that token will need to be able to be mintable and burnable. So again, how the cross-chain bridge works is that your mainnet tokens are then cloned and then minted on the Scale chain. And then if they're transferred back, they're burned from the Scale chain and then released onto the mainnet contracts. So a typical transfer process would be you would first deposit an ERC 721 onto Ethereum using the IMA contracts on the mainnet. And doing that deposit would would create a message from the IMA agent that would then identify or tell the Scale chain that it's connected to mint a clone of that ERC 721 token on the Scale chain itself. And then there, it's on the Scale chain for you to conduct high transactions or any other functionality on the Scale chain in a gasless manner or gas-free manner. And then to send that token back, for example, if you're conducting a game or some sort of workflow on your Scale chain, and then some end user would want to then sell that ERC 721 token through some exchange like OpenSea, that end user would then pay for the mainnet gas in order to exit or remove that token from the deposit on the Scale chain, and then you would perform an exit from the Scale chain where that token would be burned and then released from the mainnet contracts. Let me pause sharing right there, and I'm actually going to jump over to another screen. One moment. So to get more information about this transfer, you can go to our developer portal. So that's scale.network/docs/developers. And we have a set of token bridges here and demonstrations about how to get this working either for transferring ETH, ERC20, or ERC 721. And these guides will kind of give you a little bit more in-depth code examples about how you might modify an ERC 721 to be Scale chain compatible. Again, adding that mintable and burnable functions to that token. And then going through the whole manual setup process of adding that token onto a Scale chain and then registering it with IMA. And then down here is a transferring example. So this shows the transfer from Ethereum mainnet onto the Scale chain. In a demonstration, we have sandboxes that are also available. Let me restart this. In this sandbox, you can access and actually test. This is actually deployed onto Rinkeby, connected to Rinkeby, and a miniaturized Scale chain. In this React example, it will give you the exact process about, what is the process of manually going or setting up and registering a token, ERC 721, and then going through that transfer process. So right here, we have an account balance of an ERC 721 token on Rinkeby, and this will go through the deposit process of depositing that contract onto an IMA contract on Rinkeby. And this might take a few seconds. And that deposit will take the balance and put it into lock-in data, and it will replicate that token onto the Scale chain. So then on the Scale chain, I can make it available to do any sort of transactions or functionality. And then from the Scale chain, I can then add ETH, mainnet ETH, to pay for the exit of that token onto mainnet. It might be a little bit stuck on Rinkeby, but anyhow, this code sandbox will be available in the dev portal, and you'll be free to play around with it. Let me stop there. I've covered a lot, but let me know if you have any questions, and I'll be happy to answer them. So the first question here, can you re-explain, will a dApp run on different chains or only on one chain? How is the interoperability between the chains? It's a great question. So again, when you select a chain, that is specifically, it's really designed to be for your dApp. So for example, if you're writing a game, you would select a Scale chain specific to the size of your game or the throughput or storage needs. So for example, if you select a small Scale chain, then that would be provisioned to you. That would be your elastic blockchain resource to run your application on. If you were to build a different service layer or a completely different dApp, the idea is that you would select a different Scale chain specific for that dApp and run that separately. So like a Uniswap would go on to basically one chain, and then an OpenSea would go on to a separate chain. And then there would be configurations or specifications for throughput between those two that you could configure and select. And then the second part of that question is, how is interoperability between the chains? So the cross-chain bridge is native to all chains. And so just as you could transfer tokens from a Scale chain to Ethereum and from Ethereum to a Scale chain, you can also connect Scale chain to Scale chain. So you could have inter and cross-chain bridges between two Scale chains of different sizes. So that's possible, yeah. I'll mark that as answered. Thank you, Jess. The next question is, love your transforming building inside of Decentraland. When can we see Scale implemented in Decentraland to reduce gas price so all the wearable addicts can have their day added? I like this. Yes, so Scale Network has been very busy in getting and launching Scale chains. And so the launch is going to be very soon. The launch for Scale chains will allow first those early joiners for the Scale Innovator Program or SIP program. And these have been people that have been in groups and developers and communities that have been working with our solutions engineering team to test early versions of the Scale chains and early versions of the Scale network. So the very first releases of Scale chains will be available to them first. And then soon it will be a self-serve model. So anyone with Scale tokens will be able to, what we call stake a Scale chain, and basically use Scale tokens to get a Scale chain of a different size for their dApp to run it over a certain length of time. So this is all imminent, and we're super excited. And I love the Decentraland project, and I think it's a great example of one of the many projects that can work on a Scale chain to make things cheaper and make it easier for users and dApp developers to scale their projects. So thank you for that FUD0 engine. Another one from Jess. I heard Scale was working with Bondly. Can you tell us more about this, please? I'd be happy to, but I'm the wrong person to do that. I would defer to our solutions engineering team that's been working very closely with Bondly. But it's another great project and really excited about what's going to come out with them. But I defer to Christine and Abru from our solutions engineering project for that. Sorry, I can't give more, but don't want to steal the thunder from that group. But thank you. Awesome. Any other questions, please submit in the QA. Happy to try to make a last minute answer. And again, please reach out on GitHub. All our code is open source, so feel free to submit any pull request or discuss with the core team there. We also have a public-facing roadmap, so you can go to scale.network/roadmap to see some of the things we're working on. That roadmap is going to be populated a lot with a lot more things. And if you have any ideas or want to vote on an idea that's currently being considered and leave some additional comments, we definitely encourage you to do that. So again, scale.network/roadmap, and you'll be able to interact with our roadmap interface there. All right. I believe that is all the questions. But if you have any remaining ones, you can join our Discord or feel free to reach out to me directly. Happy to provide some follow-ups or walk you through any of the sandboxes that we have or any other questions that you have. And I would say the best question goes to Jess Newman for the interoperability. So thank you, Jess. And that concludes the session. So thank you all for joining. Really appreciate talking to you all and or presenting to you all. My name is Chadwick Strange, VP of Product at SKALE Labs, and looking forward to working with you soon. Cheers.